Hello, everybody. So this is a re-recording for the week 14 material. So last week, I recorded a video for chapter 7 in the zyBooks and screwed it up. So the two sections we have left in zyBooks are chapter 7 and chapter 9, and this is the video to cover some of chapter 7. So I'm not going to cover all of it because I'm going to assume that we're familiar with it. And also, since I already recorded a video that was damaged and had no video to it, I kind of don't feel like covering the easiest stuff that I'm pretty sure you already know. So we'll just get in here and try to do it. So this chapter is chapter 7, K-maps. And so the way it starts out is by talking a little bit about these circuits and and it wants to look at the circuits for a Boolean expression like this and a simplified Boolean expression like this. And so we learned from the labs that the point of simplifying a Boolean expression like this is that the original complicated Boolean expression may take multiple gates here. Like you can see here, this is 3 gates, but then a simplified Boolean expression here only has 1 gate, not counting the knots. So when you go through this section, I'm not going to go over it in great detail, but when you go through this section, you're going to have to do some basic simplification of Boolean expressions. So for example, I don't like this. I'm typing in VS Code, but I think I want to type in the Notes app rather, or maybe text edit. What's text edit like? Um, yeah, let's just make this a little bit bigger. Let's make it even bigger. All right, cool. So we'll type in here. So if I'm typing a Boolean expression like the one we have here, and so the apostrophes mean knots, right? And multiplication means and addition means or, right? So we learn that you can factor out and simplify these things. So if you were to look at this right here, you would say that this expression has an A, and this expression has an A, and this expression has a not C, and this expression has a not C. So you'd be able to factor out the A and the not C. And if you did that, you'd be left with the B from the first expression, and you'd be left with not B from the second expression. And we learn through our list of identities that B or not B, to be or not to be, B or not B simplifies to 1, right? Because one of these has to be true, right? If B is false, then not B is true. If B is true, then not B is false, right? So one of these two things is true. And so you definitely have a true or not true in here. And true or not true is true, which is 1. So you can simplify B or not B as 1, and then there you go. So this original expression for R gives you this simplified expression for R at the end. All right, I'm going to change the font to a monospace font. Console, courier. We'll do courier. Oh, that's so ugly. Bold? It's still ugly. Sorry, got to find a better font that's a monospace. Um, we will do it, I'm sure. Unicode monospace. That'll work. Okay. So anyway, so you can simplify expressions like this, and then there's some exercises related to that, right? So it says literals, first of all. What is a literal? I think we covered that in an earlier lecture, but a literal is going to be like one instance of a variable. So for example, A and not A, those are two literals. Um, so if it says how many literals exist in the original expression is this. And so there's one, two, three, four, five, six, right? Basically six variables in there if you count the A and the not A as separate. So six. If each AND or OR gate input requires two transistors, so they're saying an AND or requires two transistors, how many transistors does the original circuit require? So the original circuit is here. And so they say that an AND or an OR, right? AND's here or here. They're saying each of these takes two transistors. So 2, 4, 6, I guess, is what they want. Um, and or gate requires two transistors. How many transistors does the original expressions circuit require? Um, sorry, I didn't read. Each and or gate input requires two transistors. So we should count the inputs. So one input, two input, three input, four input, five input, six input, seven input, eight input. So there's eight inputs there to and or, eight inputs, and then two transistors each, so 16. All right. If each AND or gate input requires two transistors, how many transistors in the simplified expression? Uh, so two inputs times two is four. All right, so that's a big savings, right? So 16 transistors to four transistors. So when they're building electronics, right, you want to make it as cheap as possible to build. So you want to minimize the number of transistors your logic is going to take. Um, they specifically point out that this right here, J or not J, simplifies to one. They want to make sure we understand that that's an identity. Um, so imagine you're simplifying this. They want you to do it step by step. So this exercise 7.1.4. So you would factor out the C, right? And so you'd have C times D plus not D, but they want you only to write the part that's in the question mark, which is just the D or not D. So just that much is what they want. And then if you did that, C times D or not D, what would D plus not D simplify to? Should simplify to 1. 1. And then if you had C times 1, so that's C and 1, that should just simplify to C. And it does. And then here, they want you to factor out an E and a G. So if you factor an E and a G out of the first term, you'd be left with F. And if you factored out an E and a G from the second term, you'd be left with not F. So they want you to type F or not F. Same thing here, we're factoring. So if you factored it out to C, you'd have not D or D. Notice the reason they're doing this is they have a different order here, right? Up here, it was the variable and then not. So like the prime, the apostrophe is on the second term, but here the apostrophe is on the first term because that's just the order that it was written in. They want you to know that that doesn't really make a difference. All right. Also, the C could be at the end and we could still factor it out. So if you factored out the C, you'd be left with D or not D, D or not D again. All right. I'm going to skip. Oh, no, I'm not because this is a thing you need to know how to do. So 7.1.5, you have to do this a little bit. So um, if you have this and they want you to simplify, why did it have to pick the font again? Unicode, big, big, big. Okay. Um, so you have this right here and you wanted to simplify it. And you can't really just factor out, right? You factor out a C and you get D or 1. and this doesn't do you really that much good. And um, so not great. So what they want you to do is to simplify this, they want you to take this term right here. They want you to add a 1 here. So we're going to be basically working almost backwards compared to the previous simplifying we did. So you add a 1. After you add the 1, you would be able to turn that 1 into D or not D. I'm using D because I can see that that's the other variable name. Um, so you're able to actually go C to C times 1, C times D or not D, then multiply that out, CD plus CD plus C times not D, C not D. And then this is redundant to have 2 of those. So you can just erase one of them. So just like get rid of the middle term and have just the first term and the last term. And then now that you have this, now you're actually able to now you're actually able to simplify it according to the rules that we had before, where you factor out a C and you'll be left with D or not D. And that's just C times 1. And that's just C. So that step to do that, they are going to teach you here. So so you have CD plus C, so you can change the C to, or you can change the 1 here to D plus not D. Remember, they only want us to fill in the question mark. So you do that. Then you did CD plus C, CD plus C, D plus not D. You FOIL that out, or not FOIL, but multiply it out. C times D is CD. C times not D is C not D. Like we literally just did this. So we're just reproducing what I did on the other page. Then you have CD plus CD plus C not D. Uh, that's redundant. You don't need both of them. So you can just have one CD. And then once you have this, you can factor out the C, which will leave you with D plus not D. And then once you have C times D plus not D, that simplifies into a 1. So it's C times 1. So just 1. Oh, actually just C. C times 1. So I hit check every time so you can see they all came up correct. And that's a good trick. Algebra simplification by hand can be hard, sure. I did a couple of these in my video that is no longer here, but these are straightforward. So they're just like those participation activities we just did, right? So like not A B plus not A not B. So you could factor out a not A. That's all they want. Let's do number 2. Here, um, not A, not A, B, B. So you can factor out a not A, B. Let's go to number 4. Whoa. So what did they do here? Um, oh, this is an interesting one. This is an interesting one. So there's a trick here. So when you have 3 terms like this, so this was like a trick kind of, right? There's also another trick here. So another trick. This is for, what was it? 7.1.1, 7.1.1. I think number 4, right? The fourth one was what we were doing. And really, it won't let me just change the font or anything. Okay, there we go. So there's a trick here. So what you have to do is the trick is to duplicate the middle term. So what good does that do you? Well, see, the issue is this. I'll show you. So I'll explain why. So if you were to take these two terms right here, you could factor out A, not B, and you'd be left with not C plus C, right? But then the second term here, not A, B, C, like what would you do with that? Right? So you'd be able to simplify over here, but you wouldn't really be able to simplify over here. And so you could potentially get stuck. So the trick will be to duplicate the middle term. So you just add another one of these here. So now you have two of the same thing in the middle. And now what you can do is you can basically just group these first two and deal with them. And then you can group the second two and you could deal with them separately. So on the first group, they both have a not A and a not B in common. So you factor out the not A, not B, and you'll be left with not C plus C, right, from those first two. And then for the second two, if we look carefully, we have not A, not A, not B, B, but then we have C, C. So they both have a not A and a C, and you'll have a not B plus B in there. So if you duplicate the middle term, you'll actually be able to simplify both of these pieces. So the first one turns into not A, not B, and the second one turns into not A, C. So at the end of the day, that's what you would end up with. Now, what did they ask for? Well, they didn't want us to do that whole thing there. What they wanted us to do, you see, was the step that they basically want this step, right? Because you can see they have a C or not C, B or not B, just like I have a C or not C, not B or B. So the first one gets the not A, not B, not A, not B, and that second one has a not A, C, not A, C. All right, so that's sneaky. So that's kind of a sneaky simplification there. They might show you that right up here. That might be the one that they said algebraic simplification can be hard to do by hand. Actually, I think it is. Yeah, you can see that they've duplicated the middle term here. So they wanted you to know that trick. All right, now we're into K-maps. So um, we did quite a bit of K-maps in the lab, and I think people are generally okay with it. So um, when they're talking about there's zeros and ones in these boxes, but also each box corresponds to a min term. Remember that? And so um, like they are showing you here, right? Like not A, not B, that means A is zero, B is zero, right? So you need to know that. So we'll just delete all that. So like not A means A is zero. A means A is one, right? B means B is one. Not B means B is zero, right, etc. So when you are doing these, right, this box right here, the top left box, is the not A, not B box because it's 0, 0. A is 0, B is 0. And then the box here, right, A is 0, so that's not A, but B is 1, so that's B. So that's A is 0, B is 1. A is 0, B is 1. So, um, yeah, down here, A is 1, so that's A. B is 0, so that's not B. And then bottom right box is A1, B1, so AB. So the four boxes are those, right? And so when they go down here and they say J corresponds to which midterm, J is top right. So top right is A0, which is not A, and B is 1, so that's B. So they just want to know the term that the box corresponds to, not like, is it 0 or 1? Same thing for K. The K box down here is A equals 1, B equals 1, which is AB. It says L should have what value? So we haven't talked about that yet today. So remember that the way you fill in these boxes here is you fill in a 1 if your equation has that term. So like this term is not A, not B, and that's why there's a 1 in the not A, not B box. And this term is A, not B, which is 1, 0. So in the 1, 0 box, there's also a 1. So every term up here is 1, 1 in the table. You could also put it in a truth table, and you can translate it 0, 0, 1 corresponds to a 1 in the 0, 0 box. 1, 0, 1 corresponds to a 1 in the 1, 0 box. I think I said 0, 0 box is up here. 1, 1, 1, 0 box is down here. I might have said it wrong one of those times. All right. So when they ask you what should be an L, what you're supposed to do is you're supposed to look at the boxes and compare to the equation here. So this is AB. AB is the K box, right? And there's already a 1 there. Not AB, that's 0, 1 is here. There's already a 1 there. So we already have the two 1s here correspond to the two terms here, which means that everything else in here should be 0. So that's a 0, and L should also be a 0. Cells J and K differ in what variable? They want to know what variable differs here. So when you see that B is 1 here, that means B is 1 in this entire column, right? So if B is 1 in this entire column, B is not changing. So what is changing? A, right? Because this row is A equals 0, and the bottom row is A equals 1. So from J to K, what changes? A. L and K differ. So these two right here, well, this whole column is B equals 0. This whole column is B equals 1. So these two, B0, B1, B0, B1. So what changes? B. L and J differ in how many variables? L, J. So this is 0, 1. No, sorry, this is 1, 0, and this is 0, 1. So I think both variables differ in those two boxes. All right, cool. So I'm not going to do all these. I'm just going to select the shown minterms. So where does AB go? That's 1, 1. So this is the 1, 1 box. Jump ahead. Not A, not B, 0, 0. So where's the 0, 0 box? Here. Not A, not B, that's 0, 0. That's there. AB is 1, 1. So that's there. Right, let's jump to 6. Not AB. Not A, that's 0, 1. So 0, 1. And this is A, not B is 1, 0, which is down here. Cool. All right. Now we know that simplifying K-maps involves circling things. Now you can read the rules for this, but cover everyone at least once using circles. Use the fewest and largest circles. Remember, there's no diagonal circles, and you have to have a power of 2 things circled at any time. I'm not going to do all these because we'll do a more complicated problem, but like what term does this correspond to? The term is whatever variables do not change in the box. Whatever variables do not change in the box. So, so whatever variables don't change in the circle, I should say, um, is the simplified term for that circle. One circle equals one term in the answer. All right. So this one right here, you say what variable does not change? So this entire circle is b equals 0, right? Right, b 0. The entire circle is b equals 0. And so b equals 0 is not b. All right. Is circle M necessary? Yes. If you got rid of M, you would not be circling all the ones. You have to circle all the ones. So, um, is it necessary? Yes. Is circle P a good circle? You want the circles to be as big as possible. So you wouldn't want this circle. You would want to make P bigger and circle both of these together. Circle the entire top row together. All right. So use largest circles. Okay. All right. Let's do one or two of these. This is challenge. Let's do number 2. All right. So what do we do? Oh, we're adding circles. So this would be in a circle, and this would be in a circle. You can't circle them together because you can't make a diagonal circle. All right. Now, when you have two horizontal like this, you would circle them together. So you select both of them and then hit add circle. That's what you got to do. Let's see, blah, 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 blah. The designer had the original equation UB plus U not B, and it simplified to U. Does that mean they did it wrong? Um, no, right? This is kind of a weird thing. They simplified it and this is what they got. And they're saying, is that a problem? Well, no, right? I mean, if you simplify it correctly and this is what you got, then this is what you got. So it says the designer incorrectly captured the original behavior. No, you just get what you get. The simplification on the K-map is obvious. That's the point of K-maps is that, you don't have to do algebra. So they should be quote unquote obvious. All right, you can just do that. All righty, 3 and 4 variable K-maps, same deal here. But remember that when you're dealing with these larger K-maps, that two of the variables are grouped together now. So like your A, this is A equals 0, this is B equals 1. But now each column here is like this is B equals 0, C equals 0, or not B, not C. This is not B, C, right? So you were doing the C and the B together. This is BC. So BC. So that's yeah, 1 is BC. This one is B, not C. Okay. And they filled in some of these, but not all of them. Just because. All righty. Just like always, you could potentially have a truth table here. And if you do, every 1 in the truth table is a 1 over here in the K-map. So like when you have 0, 1, 0, right? I'll just do one of these. If you had 0, 1, 0, that would correspond to not A, right? B, not C, right? So 0, 1, 0 is not A, B, not C. And then where would that be? Well, I guess actually just 0, 1, 0, you can see here. A is 0, and then the other two are 1, 0 together. So A is 0, and then you go over here to 1, 0. So this right here is this term, not A, B, C. Not A, B, not C, right here. And that's the orange one right here, goes there. Okay, so there's four ones here, so there's four ones here. Everything else is automatically zero. All right. Um, so you can see which term is what there. Uh, you can double check these for yourself. So like J here is 0, 0, 0. That's not A, not B, not C. K, what's K? K is here. So that's 1, 1, 1. That's ABC. Um, everything up here, every term up here corresponds to one thing here. So um, L, what's L? L is here. This is 0, 1, 1. 0, 1, 1 is not a BC. And looking at this, not a BC is right here. So this corresponds to the L term. So it should be a 1, right? Because we have the term here. So we fill it in with a 1 up here. All right, I'm not going to do all those. You can do a few of these. Not A, not B, C. That's 0, 0, 1, 0, 0, 1. Do number 3. Not A, not B, not C. 0, 0, 0. Right there. Number 5. Not A, not B, C. 0, 0, 1. 0, 0, 1. A, B, not C is 1, 1, 0. 1, 1, 0. All right, pretty straightforward. Circling goes the same here. There's a trick though. I want to see one. And the trick with these is that you can actually circle, the circle wraps around from the right side to the left side. So if you have a 1 here and a 1 here, you can actually use one circle to circle them. That's a trick you got to know. Um, as far as figuring out what the term is, you just remember this rule up here. Whatever variables don't change in the circle is a simplified term for that circle, and one term equals one circle. So like the J here, you say, what doesn't change in J? Um, well, the A is 0, right? In the entire circle. So that's one of the things that doesn't change is the A is 0, which is not A. And then you say, does B change? B is 0, B is 0. So that's not B. And then the C, 0, 1, right? The C is 0, the C is 1 here. So the C changes. Um, so what doesn't change? Not A, not B. That's what doesn't change. All right. So same thing for K. What is K? You say, what is K? Well, in this circle, A, 0, A, 1. So A changes. What doesn't change? Well, in this entire column, the B is 1 and the C is 0 in this entire column. So the B and the C don't change. So the B is 1, which is B, and the C is 0, which is not C. All right. So I'm going to skip one and go to this one here, P. So on P, when you have just one thing circled by itself and you're trying to answer the question, like whatever variables don't change in the circle, well, if you only have one thing circled, nothing changes. So nothing changes in the circle. So whatever this circle is, which is 1, 0, 1, A, not B, C, all of the variables don't change. So what is P? It's A, right? Because there's one for A. B is 0, which is not B, and C is 1, which is C. All right. All righty. This is the same thing. So maybe I'm not going to do it all. Let's see here. Is circle P necessary? Yeah. Oh no, P is not necessary because both of these ones are circled with R. Both of these ones are circled with P. So, or sorry, with Q. So the P here, you could just get rid of the P and everything would still be circled. So you don't need that. Is circle Q necessary? Yes. You do need Q because this one needs to be circled. And if you got rid of Q, then it would not be circled. Is S a good circle? Last problem. No. Remember that you can wrap the circles around and you want them to be as big as possible. So S should have been circled with this R, not R, with this one right here. So this one and this one should be circled together in a circle. The way it is now, the term you get for S will be bigger than it needs to be. So that's not a good circle. Alrighty, let's go down here. Fewest and largest circles, they just want us to circle things again. So one, add circle. Skip to number 3. This and this can be in the same circle. Let's go to number 5. Wait. Oh, I don't know what I was looking at. These two can be circled together. And then this is the only other one. So it ends up in a circle by itself. Let's go to number 7. These two can be circled. These two can be circled, right? And you wouldn't want to circle something by itself. You want the circle to be as big as possible. Cool. All right. Now this is writing the simplified terms. So again, when you just have one thing by itself, you're just writing whatever that term is. So this is A. A is 1. B is 0, so that's not B. C is 1, so that's C. There you go. I'm going to do 2. These two are circled together, so you have to ask yourself what does not change. So in this circle, A is constantly 1. So that's A. And in this circle, I see the B is 1, B is 1. So B does not change. But I see C is 1, C is 0. So the C does change. So you don't write it. Number 4. This circle right here, I guess I don't know which one has to be written first. This circle right here, what does not change? Well, A changes, right? 0, A0, A1. So A changes, so we don't write it. And in this circle here, B is 1, which is B. And C is 0, which is not C. So that's the blue circle. And then in this circle, again, when you have one thing circled by itself, you're just writing out what that term is. So A is 0, which is not A. B is 0, which is not B. And C is 1, which is C. All right. One more. 6. So we've got 2 circles here. So we'll do the blue circle first. So blue circle, A is changing. A is changing, but BC is just 0, 0. So that's B, not B, C, not C. And then in the orange circle, what doesn't change? Well, A is 0 in this circle. So that's not A. B is 0. So that's not B. C changes. So we don't write it. There we go. All right. Let's keep going. You can circle, this is just more circles. You can circle 4 things at once. So you could either have an entire row of all ones like this. You could also have 4 things circled together in a group like this. And because you can wrap around, you can even have these 2 things circled with these 2 things in one bigger circle. So a circle covering which cells should be drawn. You could circle this one, this one, this one, this one all together. which is this, I guess. You want, and then it says a circle covering which cells could be drawn. Then you could circle these two together, which is 1 and 5. Cool. 4 variables. Yeah, so if you have 4 variables, then they wrap around left and right, but they also wrap around top to bottom. So this can be circled with this. This can be circled with this. So this orange circle here is actually circling 4 things. This corner to this corner, but also this corner around to this corner and this corner around to this corner. So they're showing you that you could have one circle for all those corners. Crazy. Here's some more circles. Um, all right. So if you're trying to do this again, the same rule applies here. So like if we're trying to do box M, what is box M? You need to say what does not change in that box. So um, looking in this box, I see, just take the variables one by one. So in the blue box, I see AB is 1, 1, 1, 0. So I can see that this is A1, A1, right? So in the blue box, A is 1. So that's A. But in the blue box, B is 1, B is 0. So B changes, so we don't write B. And then you move to C. And so you say in the blue box, actually C is just 0 in the entire blue box, right? Because the whole column is C0, D1. So C is 0 in the entire box. So that's not C. And D is 1 in the entire box, which is D. So what is box M? It's A, not C, D, which is there. They did it with algebra, but we did this. What's box K? I don't know where K is. Let's find it. Where's K? K is all the way here. So you say, what does not change in that box? So in the entire box for K, A and B is 1, 1 in the entire box. So that's A is 1, B is 1. And then in the entire box here, I see that C is 0, C is 0, C is 1, C is 1. So C changes in the red box. So we don't write it. And then D, D0, D1. So D changes in the box, so we don't write it. So in the red box, what doesn't change? Just the AB. So K is just AB. Like that. All right. We can do what's next. Let's do J, I guess. I don't know. I'm doing them out of order. J is up here, orange box. So in the orange box, what doesn't change? So you have to look. So do the variables one by one. So A is 0, A is 0. Okay, so A is 0, which is not A. B changes, right? B0, B1. So B changes, so we don't write it. Let's move on to C. This is C0. This is C1. So C changes, so we don't write it. This is D0. This is D0. So D does not change, and it's 0. So that's not D. So J is not A, not D. Process of elimination. We're done, but we'll just do it anyway. N equals. So again, you're asking yourself what does not change. The bigger the box, the smaller the resulting term. So in this big box for N, does A change? We see A0, A0, A1, A1. So A changes, so we don't write it. What about B? B0, B1. Okay, B changes, so we don't write it. So we move on to C. This is C1, C1. Oh, so in this entire box, C is 1. So we write C. And then D, this is D equals 1, D equals 0. So D changes, so we don't write it. So the box in is just C. All right. And they did it with algebra. All right. So cool. K-map examples. See what we can do with these. Consider the example above. Type numbers as 2, not 2. The K-map had how many ones? Here's the K-map. 1, 2, 3, 4. The designer drew how many circles? They drew 1 circle, 2 circle, 3 circles. Blank circles included the cell for Y1, Y2, Y3. Uh, okay, so Y1, Y2, Y3, that's like 1, 1, 1. So the 1, 1, 1 cell is right here. And if you look, this this box or this circle or this one is included in all 3 circles, right? The blue circle includes it, the green circle includes it, and the purple circle includes it. So how many circles included that cell? 3 circles. If each and OR gate input is 2 transistors, the final circuit requires how many transistors? So we count the inputs to the ands and the ors. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So 9 inputs to ands and ors. And then we have to do 9 times 2 to get 18. And that's how many transistors. All right. An arbiter arbitrates which of several competing items win. If only one button should be pressed at a time, but a user presses 2 or more, an arbiter can decide which pressed button will be recognized. If 2 devices simultaneously try to access a resource, such as a printer, network cable, or storage, an arbiter decides which device will get access. And they're saying that this does it. Okay. Um, a keypad may have 3 buttons, but only one should be pressed at a time. An arbiter outputs probably exactly one winner of multiple button presses. Although a shock to the user to discourage multiple button presses is also a good option. Suppose a 4th button D is introduced with a variable lower priority. Based on the equations for STU, what would be the equation for V? Okay, let's see how they did this. We did not read. Keypad has multiple buttons. Only one should be pressed at a time. An arbiter decides which button wins. An arbiter decides which button press wins. So for ABC, I'll put 1, 1. A has the highest priority, B has the next. So if you, okay, so here's what they're saying. So like the buttons are ABC, right? So if you type in 101, right? That means they're pressing, they press button A and they press button C. So which one wins, A or C, right? And the answer was A, because A, we kept the one for A and we just got rid of the one for C. So this is A and C. This is just A. So A had higher priority, so we threw away the answer for C. A designer can capture this behavior with a truth table. So like what they're doing here is if you look at the truth table, then if somebody just presses button C, then we output button C. If somebody just presses button B, we just output button B. If somebody just presses A, we output A, right? So one button by itself, we don't do anything. But if 2 buttons come at the same time, then A has more priority than B, and B has more priority than C. So A is the has the most priority, B has the second most priority, and C has the third most. So what you see here is that they're pressing B and C, and the output is just B, right? If you think A, B, C again. So they threw away the C value. C is the lowest priority. And here, if they press A and C, you throw away the C value and you just keep the A value. And here, if you press A and B, we just keep the A value. And if you press A, B, and C, we just keep the A value. Okay. I think I see how that works. So it says, suppose the fourth button D is introduced and it's even lower priority. What would be the equation for B? Okay. Or the equation for V? Um, well, what are the equations? Um, I don't like this because it says based on the equations for S, T, and U, um, where they didn't write an equation for S, T, and U. Oh yeah, they did here. So S was A. So A is the highest priority. So the equation for S, which is corresponding to A, is S equals A. Um, but for T, which is button B, you only output button B if you're pressing button B, but you're not pressing button A, right? Because um, this works because you're pressing button B, but you're not pressing button A. Because if you press button A is higher priority, right? So you don't activate button B if they're pressing A. So you have to press B and not be pressing A to get an output of B. And similarly for C, the lowest priority, you only output C if you're pressing C and you're not pressing B and you're not pressing A. So if we wanted to add an even lower priority button, right? If we had A, B, C, and D, so we add this extra even lower priority button, then the equation for it, we have STU, so the next equation would be V, they say. And then what would it be? Well, you have to be pressing D, or sorry, you have to be pressing button D, but not pressing A, not pressing B, not pressing C, but you are pressing D. That's how you would write the equation for V for the lowest priority button. So it'd be this. Interesting. Suppose a fourth button D were introduced with output V and lower priority than C. Would any of the equations for S, T, and U need to be changed? No, I don't think so. Um, the only, like, when you're writing like the equation for U, it's button C, and you need to say not for the buttons that are higher priority. Um, but the equation for A, which is the highest priority, doesn't refer to any of the other variables. And the equation for B doesn't refer to C because C is lower priority. And so you never need to refer to the lower priority variable, is what that's saying. What is the word for a component that decides which of the multiple inputs wins? Is it an arbitrator, an arbiter, or an arbiter? Okay, spelling. This is spelling. Um, it says in law, a person who settles disputes is the arbitrator. I think I've heard in like chess. So like if you're having a chess tournament and somebody is running the tournament, I think they're called arbiters, actually, not arbitrators. Alrighty. Anyway, K-map. So K-map to truth table to K-map, you just mark where the ones are. So you look here and you see 0, 0, 1, 0, 0, 0, 0, 0. So this one corresponds to 0, 1, 0. So you just find where 0, 1, 0, 0, 1 0 here, right? Oh, it was literally listed. Cool. Let's do 2. So 0 0 1. So you have a 1 there. So you find 0 0 1. 0 1 1. Where's that? Next to it. So you put a 1 there. This one is 1 0 1. So you find 1 0 1. And so there's 1, 2, 3 ones over here. So you mark 3, you fill in 3 ones over here as well. And that's all you're doing. All right. So we're done. That is all of chapter 7. So we did, I think, all of it. So we're going to stop here. I think that's plenty long enough, and I will talk to you guys later.